Hey everybody, in this video we're going to talk about something called linear modeling. And basically what it is you're going to have a y equals mx plus b, which is a linear function, and it's just going to have a context this time. So what we'll have to do is read a text, and we've got to decide the rate of change from the text, because remember that's all we need to write one of these equations is a slope, which is the rate of change, and we need an initial amount, which is your y-intercept. So let me get in here and show you some of these notes I've prepared for us. All right, so the linear function is going to be of the form f of x equals mx plus b. It's the same as a y equals mx plus b. And you'll find oftentimes they'll use letters that remind them of what the context might be. Like if it's a cost function, they might call it c of x or just c equals, right? So get used to maybe letters not being always y and x, okay? All right, so I highlighted this in yellow. It says m is the rate of change, and remember it's the same slope you've always used. When reading an application problem, look for keywords that indicate a rate, and those are things we've been looking at. Miles per day, and these are just examples. They're not the only ones. It's just the way you need to be thinking. Miles per day, dollars per hour, etc., right? It could be gallons per minute. Just look for those rates, that language that indicates they're giving you a rate. Now that's the easier type, and they just give you a rate up front. All right, and you'll see what I'm talking about in a minute. Another thing they might give you right up front in the text is the y-intercept, because remember that's what you need to write this equation. You need a y-intercept. Okay, so when you find this y-intercept in context, it's an initial amount. The reason being is if you're dealing with a function that has a time element and it was 0, how much did you start with, or something like that. All right, so, and don't forget your y-intercept is always 0b. Another thing you got to think about when you're looking at these is the biggest thing you have to understand is this will be a model that has a job to do. Okay, it has an input and an output. And I guess the best way to talk about that is come down here and look at this first example. It's a really simple one that I made up. And it's always a good one, I think, because it makes a lot of sense. All right, a cab company charges an initial fee for showing up of $10. That means this. The cab's coming to pick me up from my hotel room or something like that. Well, they tell me, well, there's a $10 fee to show up. Whether you take a ride or not, you owe us $10 when we get there, okay? And then it's $2.50 per mile. And it says, write a linear function that models the cost of the cab ride. Okay, what will this model do when I get it made? So that's the question I think really should be answered before you build your model. And the model will predict the cost of a cab ride, right? The model will predict the cost of a cab ride. Now, what's this going to depend on, right? We know this is going to predict the cost of a cab ride. It's not depending on this initial $10. I know I'm paying that. It depends on the number of miles. If I went 5 miles, well, it's a different cost than 1 mile, right? So if I went 1 mile, it'd be $10 plus the $2.50 and so on. So the model will predict the cost of a cab ride for any number of miles. Okay? That's what this thing's supposed to do. All right, so let's take a second here and maybe work this one out, and we'll talk about independent and dependent and how this whole thing really should look, okay? So let me get in here with a drawing tool and clear that one out. Okay, so what we're talking about here is this cab ride. We want to build a function that does this. You tell me how many miles, and I'll tell you the cost, okay? So we want to build a c equals mx plus b, right? The cost is going to be a function of the number of miles. So this is your independent variable. Right? And your cost depends on that, right? The number of miles. So we'll write right here, x is the number of miles. C is total cost of the ride, right? All right, so let's go back and read and extract this information. We kind of might already have talked about it. Now, the initial fee, like we said up here, if you're looking for that language like I'm talking about, it's indicated right there where it says initial fee for showing up. So that 10 is your initial fee. That's your y-intercept. Per mile, $2.50 per mile. This is a rate given to you, I would say explicitly. They're just telling you what it is. All right, so we're going to write our function. But let's first identify this. So we know our rate is m equals 250. Our y-intercept, b, is 10. We can put 0.00, but really won't make any difference for the function we're going to make. So our function that can do the job here is c equals 0.25x plus 10. All right, now does this thing work? Well, if you just take a look at what it's doing for us, I put in 1 for x, I get 10 plus 2.5, so I get, it would be $12.50 for a 1 mile ride. 2, this would give me a 5, right? So I'd get 15 for a 2 mile ride. So it does predict the cost of the cab ride. And note here, for 0 miles, you're still paying that $10. That's that initial fee, that y-intercept. Okay? Let me make sure we covered all our bases here with this one. But I'm telling you, the most important thing out here is answering this question right here. If you can't answer this question, then you really don't have control of the situation. What does the model do? And you need to know input and output. So we'll put that even right here too. Miles go in, cost come out. If you don't know that, you don't have good control over what you're working on, okay? All right, so this is the first video. I think we're going to end up with maybe 2 or 3. This is a fairly simple one, but it's the way to start thinking about wrapping your head around this. Because sometimes we're going to find that they don't give us the initial amount and a rate given in the text. This would be an example of, I guess, a fairly easy one. And we'll look at some others. So I'll see you in the next video. I hope this is helpful.